Excellent. Well, thank you very much for that, Max. And hello, everybody. And it's great to see so many people joining this call. Let me just turn my screen a little bit more. Okay. So what I'll do is I'll first of all start by introducing myself and then very quickly move on to the topic in question, which is how can testing be integrated into DevOps? You'll find that the answer, and it's a spoiler, is that it depends. It depends on where you and your organization is in the journey and what you can do. But I'm hoping to spark ideas, questions, thoughts about DevOps, what you can do and how to enable this to happen within your organization. So for a moment, just about me. So my name is Stevan Zivanovic. I've been testing now for 32 years. I've seen testing change significantly. I started my career initially as a mechanical engineer and then as a software test engineer for Rolls-Royce, working on embedded flight safety critical systems. And after a phenomenal grounding there, I've subsequently worked in multiple organizations in all sorts of sectors. And I've really seen the IT market and testing change significantly over that period of time. However, there are some fundamentals that have never changed and are an axiomatic part of the work that we do as testers. Now, today's talk is based on work I've done with experimenters on a number of client sites, in particular with a large insurance company, where they were looking to move to DevOps as an organization. And part of the systems that they were looking to move included mainframes. You could argue, can you do DevOps with mainframes? And there is an awful lot that can be done, is the spoiler alert on that one. So without too much ado, let's go straight into the presentation. I hope you enjoy it. Please put questions in the meeting chat and I will pick them up at the end of the presentation. So let's go. So let's start with the really tricky one. What is DevOps? Almost everybody I've asked about how would they define DevOps, everybody defines it slightly differently. If you search online, you'll see that there's a lot of information going around about which is more related to how a company wants to sell its services rather than a true definition of what DevOps is. After seeing multiple versions, I thought, actually, do you know what? And part of the talk, we touch on AI a couple of times, is I thought, well, I'll ask ChatGPT. And ChatGPT came back with what you see on the screen, which actually I don't think is too bad a starting point. By the way, when I'm talking about DevOps here, I'm not separating out DevOps, DevSecOps. To me, security is part of this. It's an intrinsic part within this. So when I'm talking DevOps, I'm talking DevOps, DevSecOps, and any other labels that are out there around this part. Now, the big thing for me, and what I find really interesting, exciting, and enthuses me in DevOps is that we are now talking about engineering. you may have been aware of previous debates online and at various conferences about, is testing a profession? Is it an engineering practice? Is it an artisan practice? And so on and so forth. I land on the engineering part. To me, we should be engineers. We should be professionally recognized as engineers. And it is a challenging technical work that we do. What DevOps does is that it helps enforce that as a concept, because by the very mechanisms that you have to follow to do DevOps, you need to understand how you engineer software. And on my last point on the slide, and it's worth, is that up until probably the mid 2000s, probably even 2010s, we used to talk about software and software programs like building a house. You start with a base and then you layer it and layer it. And so it was more of a construction process. Whereas what DevOps does is it shifts the mindset into this being a manufacturing process. So rather than delivering a house, you're delivering one aspect, then you deliver another piece, and then another, and so on. So it's about delivering rapidly small iterations and in small iterations. So next, we'll just go on to a quick poll online. So Chris, if you don't mind, just give yourselves a minute to select the one that is true out of the options that you have in front of you. That's great. Thank you very much. There's some good voting going on. Just a couple more of you to vote. And just give it 1 second more. So the question is, which one of the following is true? And Chris, I think we'll end the poll at this point and share the result. Thank you. Excellent. So which of the following is DevOps replaces Agile? DevOps doesn't actually replace Agile. It uses the Agile techniques that we've got to help in the delivery of it. So that's false. DevOps is incompatible with ITIL. Again, no. It uses a lot of the practices that ITIL has. Or what happens is that you change the way that you implement ITIL, but the fundamentals behind ITIL definitely apply. DevOps means eliminating IT operations or no ops. No, it's just that these people are far more closely integrated into the teams. It's a one team mentality rather than having multiple different teams. So if you're an IT operations person, your job is still safe. DevOps is just about automation. No, there is a whole philosophical pipeline changing, requirements change approach to how we deliver it. Is DevOps a cultural change? Yes. And this is possibly where its single biggest constraint is as well. And I'll come on to that in a moment. So next. So in terms of adopting DevOps, how do you go about it? The first and foremost aspect I've found is that it's a personal mindset change. I went through this. And the more I've seen this work progressing in organizations, the more I see people who are working within the teams suddenly going, oh, I need to change this. I need to change what I think about testing. I need to think about how I approach this differently. So that personal mindset change is huge. The second one is it's an organization change. The way that you expect change to be delivered will be different. You've got to expect that the people that you are delivering change for expect things in small batches, that they expect things to be done very, very quickly, but also expect things to be able to change quickly as well. So something gets released, it doesn't work as in the way that you expect it or quite how you expect it, then you change it again, but you change it really, really quickly. You know, you move away from, 1 year pipelines of work to next week we'll release X number of changes. And then finally, it's the technology change. You cannot do DevOps, I would argue, on certain systems until architecturally you have changed what's happening. I mean, one of the big factors in there is you move to what's known as a loosely coupled architecture. In other words, you can release a change in one area without it affecting others. So going to the point around DevOps is that, for me, is that we make small changes quickly and frequently. If you look at some of the well-touted organizations following DevOps, they're changing multiple times a day. However, what they release is tested, and you only consider it as actually being the change made, that the change reaches production. Now, that could mean that actually it reaches production, but it's switched off because it's not ready to be used. But you still release very rapidly. The idea being is that small changes are significantly less risky than large changes. That's one of the underlying principles here. And then, because we're trying to do this very quickly, frequently, is that we actively monitor. And one of the key factors in DevOps is that there is a huge amount of automated monitoring going on, ideally within your test environments as well. So there's significant change right throughout the whole organization to get yourselves into a situation like this. So for the, as this is targeted towards testers, I'll just bring up these two diagrams, well touted, well known, used throughout the industry. These are still valid. They don't fall away. It is critical that a lot of testing is done and a lot of automated testing is done. And then we come to the challenges that come with automation, but I'll deal a bit more with that in the next slide. But test automation is not the be all and end all, as you'll see. So the next one is a solution just showing a flow going from a user story through to something being released into production. So what does that mean? It means that you've got a whole pipeline demand system of changes. And a change you define as a user story and acceptance criteria. What this diagram doesn't show, and I've deliberately excluded, is the multiple workflows preceding this to get to a point where you have an agreed user story with suitable acceptance criteria that enable you to then start working. You have your sessions up front to review and analyze your user stories, to expand them out to provide what we call examples. So things like specification by example are critical here. And where, one of the big questions that's often asked is, where does the tester get involved in all of this? Well, one of the key factors here is that the tester gets involved right up front, working with the business or the business sponsor in the team, saying, okay, let's start creating what's known as BDD, or behavior-driven development statements. And through that, you can then code your tests. So the top line follows what the tester can do. In parallel, you've got the developer writing, and I've deliberately done it in the unit test and then application. So one of the big factors here is that test-driven development approaches become, I would argue, essential. Others may say you could get away without it or whatever, but ultimately you write your test first. As a developer, you write your code. Does your code meet the test? As soon as it does, then you can move it on. And in organizations that do this, you find that the quality of coding is significantly improved. The number of defects found further downstream decreases. Remember, at the same point, you're not just releasing code, but you're potentially also releasing infrastructure. And you need to be building your infrastructure as code. So the key being is that you put into version control everything that is needed to define your system in production. In theory, you could trash production and start from your Git repository, for instance, and deploy everything. And that will build you your environment, your test data, your monitoring, your code, your applications, everything. So everything is codified. So then you use tools like Jenkins to build. You build, then you run unit tests as well, just make sure that they pass through. You create your package. Depending on which software system you're using, that packaging can be a big piece of work. And then you go into the washing machine cycle, as I've nicknamed it, which is you create your environment, you deploy your code, you seed your environment with your data, you run your tests, and then you destroy your environment. And then you repeat that through multiple layers of environments. I'll talk a little bit more about environments on the next slide. The idea is that all of this is automated, so that by the time you get to a point where you are wanting to release into production, you've tested this potentially in 5 or 6 environments of growing complexity, with growing data complexity as well. until you get to a point that you can do what's known as a blue-green deployment. You deploy it into an environment, and potentially you could start launching it at that point into production. Now, the question comes in is, where do you do manual testing? For some organizations, they do their blue-green deployment and they test in the not live version. And as they gain confidence in there, they start opening that up to people to use in real life, but with a huge amount of monitoring. That monitoring tracks paths through the critical business paths through the system. So the way of thinking about it is that I've got an online retail, and I expect 5% of all traffic to fail on payment. If that suddenly starts drifting up to 7%, 10%, you go, actually, I think we've got a problem here. You switch back to the old version and investigate. So you can do some testing in production, and you rely on your monitoring to do that, and you use real people to use the system. Now, obviously, as you can imagine, that is a idealized solution where you have to have a significant investment throughout the whole organization to accept that this will work. Tony's asked a great question, actually. I think it might be worth picking up at this point. So does this apply for config and minor customization of COTS products? It can do, but you have to, it won't work with all COTS products. The COTS products have to be set up in such a way that allows you to follow some of these aspects. Where it can, it shouldn't stop you from engineering a process where you release into production on a frequent and regular basis. The principle being that small change is better than grouping many changes together, and how you make that work. So on to the next slide is environments and data. So I mentioned about these multiple different types of data. And as you can imagine, the bigger the more complex your environment, the more you need to add to it. And so you need to be able to provision your environments. You need to be able to provision your data. How you add data into an environment, it becomes critical. Some organizations will argue that they can never do this because they're trying to load data from a data warehouse, which is, multiple terabytes, huge numbers of data points. So you can't do this with a data warehouse. However, the concept is then, what can you do? And how you apply that data. So the more you can engineer the data so that you can add it, work with it, and then tear it down is ideal. You need to think about service virtualization as well. And this is where I mentioned them earlier, is loosely coupled architecture. So if you've got a loosely coupled architecture, it means that you can then potentially isolate whole applications or areas of applications through service virtualization. And it then allows you to test rapidly without having a significant dependency on downstream environments. Obviously, the more of your environments that can be provisioned through code, so through a pipeline, so you can then, on a click of a button, you will get your services, virtualized services spin up. data applied to them, connectivity applied to it. So it's all done as code. The more you can do that, obviously, the quicker you can go through this. As soon as you need to start doing anything manual with this, it's the issue is manual work is not repeatable and error prone. So you want to avoid that as much as possible. And then you've got how do you replicate that when you go into production? The idea here is you're doing something time and time again before it goes into production in a similar way, so that you gain confidence by the time you go live. And one mention here is about the types of data that you use. Certainly for some of the earlier environments, you can use small change-specific synthetic data. The bigger, the more integrated your environment, the larger and more integrated your data becomes. So test data management is critical here. For those of you who do a lot of test automation, it's important through, you're painfully aware on the dependency on a stable environment with reasonable data. In a DevOps methodology, it becomes fundamental. So a little bit of a summary then. One thing I'm just going to go back to this graph here, and I just there was one thing I wanted to call out here, is that the whole idea around this is that if there is a fault found at any point in this workflow, particularly with the blue arrows, the idea is that you don't carry on. You stop, you pull the undone cord. If you mean that, you'll hear this term. So the idea is that this is a Toyota production line analogy, where there is a cord by every station along the manufacturing path for a car, and as soon as a problem is found, you pull the cord. The culture behind that is such that people are encouraged to pull it. It's not done as a, oh, why did you pull that? It's a, you've pulled it, what's wrong? Let's fix it. You swarm it, you get people onto it, you fix it, and then you restart. You don't just carry on thinking, oh, I've got 5 defects, I'll fix them next time. If they're stopping you, if they're stopping this process from working, you don't proceed. You stop, you go back, make your code changes, and then carry on through. Okay, so in the last for the last five minutes, I'll just talk about structuring what you can do. So planning. So this goes from what you may see as documented test policies, test plans, test strategies, test plans, lots and lots of layers of documentation, to something that is part of the overall SDLC. It's refined regularly. You can define it. You may find that you have documents somewhere, or you use a wiki and you say, this is what we're following at the moment, so people have a clear visibility of it. So we don't move away from no documentation, but you move to a point of documenting what is needed in an easy to access, easy to amend place, so that you can continually update. You don't want a master test plan, let's say, that can take a month to write and then another month to update. In the meantime, you've done 5 releases. It doesn't work like that. You've got to think about how you structure your documentation differently to make it follow the DevOps principles of small bite-sized chunks that can easily be modified. You've got traceability of it, and you can, and it's clearly communicated. Design, lots of detailed test steps with BA reviews, manual design. We're talking about trying to do automation first. you go straight from your BDD statements into test automation. So creating your test automation framework, so that, as you write your syntactic BDD statements, you can hook them straight into them. Writing new bits of code for the automation then becomes easier. So it's a fundamental change here. Execution. Arguably, most people now do predominantly manual testing with some automated testing somewhere. The way you flip this for DevOps is that it's all automated with exceptional type testing, manual testing. So things like exploratory testing, and possibly some early testing with business sponsors so that they can try out a feature before they release it to a wider audience. But the predominant testing effort here is that it is all automated. Reports, defects, you've got your manual daily, weekly reports, test closure reports, all of that. None of that makes sense. Now, I'm being a bit provocative by saying no defects, it's just tasks. It might help some organizations to flag issues found that aren't fixed straight away in the pipelines, to flag them as a defect if it helps. But the key here is that having a weekly test report saying that, we've got 30 defects, 20 new defects, 10 closed, we've got this, that, and the other. Within this concept, that makes no sense. And ultimately, the argument is, does it add value to the delivery of software? And the argument will be, well, I'd rather you spent your time automating, doing exploratory testing, making sure that the pipeline is as refined as running as possible. And the true measure is the fact that, have we had to roll back anything in production? And environments, I've already made the point here, I think, is that we go from static environments necessarily with long lead times if you want a new one, multi-tenancy ones where you've got multiple people using them, to an automated build, deploy, and remove on-demand system. So as soon as your pipeline needs an environment, it can build it. So that's how I see testing changes. So open back to you guys is that, what can you do next? Now, the one thing with DevOps is that it absolutely embraces what's known as Kaizen, or good change, or it comes from a continuous improvement process. It stemmed from Deming going out to Japan post the Second World War, talking to them about how to do engineering change. And this was all about doing rapid, small changes. I mean, the biggest one that for the Brits on this call, we've got the British cycling team in 2002 didn't do very well at the Olympics, and then 2004, and then in 2008 it started winning significantly, and they applied a lot of these Kaizen changes, in as much as if something improves your performance just by 1%, let's do it. And it's by doing lots and lots and lots of small behavioral changes that you suddenly end up delivering something that is highly, highly performant. And the questions come back to you is, well, how do we go about implementing DevOps? Well, first and foremost is, do you know what DevOps is? Have you read a book about it? Have you done some research on it? Great that you're here talking to me, on this call. I can give you my view, but there is a lot of information out there. So is there something you could do short term? Is it like tomorrow go and buy the Phoenix Project, which is probably your best starting point book if you want on DevOps. It's highly readable, highly easy to consume, but makes some very, very good points. And then go away and ask yourselves questions about what you do in your role in the business that you're in. So, what can I do to automate test data? Can I do something that will help me automate an environment build? Can I do something that helps me generate test data so that I can use that more frequently? Can I automate my tests earlier? And the big one nowadays is AI. There are a number of AI-enabled tools out there. I would thoroughly encourage you to try using something like either Microsoft Copilot or ChatGPT, and in there, upload a section of your requirements as long as they're not confidential. Remember that you're putting stuff up into the cloud, and ask it to define you some BDD statements. It's amazing what can be generated extremely quickly just by using those tools, that you can then potentially, it usually needs some editing, but it significantly accelerates you along the way. And then there's other test automation tools. Postman, for instance, have got a AI element in there that helps you do whole API journeys, and you can model them. For a previous project, that would have been phenomenal if I'd had that tool at that point. But this all is about you making a small, good change. And the way you go about it, the principle is very simple, is set yourself a goal, short, medium, and long-term goals, and then do one small thing to achieve your goal on a daily basis, even if it takes you 2 minutes. It could be, I'm going to look at one article on DevOps online tomorrow. Great. Do that. And then see if you can repeat that. And if you keep repeating that until you've achieved your, let's say, your first short-term goal, brilliant. You're well on the journey then. Cool. So final point then is, Chris, if you could do the final poll. Lovely. So we're going to apply Kaizen to yourselves. So the challenge I'm setting you is, what one short-term goal will you target within the next week to apply this Kaizen techniques to? And there's no right or wrong answer. This is, what do you want to learn about? And then remember what you've clicked on and evaluate it this time next week. So next Wednesday evening, when you finish your day at work, sit and go, well, actually, did I look into test-driven approaches? What have I actually learned? And then you can, and then go, well, actually, I want to learn more about that, carry on. Or you think, actually, I've got enough of that for now. What can I move to next? And similarly, we do this with automated testing, environments. The subject area is up to you. I'm not driving you to do any one thing. I left the other in there for if you think, actually, I'm not interested in all of this, but I want to go down a whole another route. But the key with all of this, and one of the really nice things about DevOps from a cultural perspective, is that the push comes back to yourself to do something to improve your ability. And by you improving by a bit, that should then start rubbing off onto people around you. There's no harm in going back to your teams and setting that, perhaps even a team goal. What can we as a team in a week's time do? Set up a half-hour call towards the end of that week and say, well, what did we learn? Share that, and in sharing you learn more, and you also educate others as you're going along. And once we just finish off this poll just for a minute, if anybody's interested in Kaizen, I mean, there's a huge amounts of it on online. There's plenty of great books from an engineering perspective, but also people are now starting to talk about Kaizen as a personal development methodology. And again, it's a way of approaching problems which I thoroughly recommend looking at. If you're interested, there is a book called Kaizen by Sarah Harvey, and I'm listening to that one on Audible at the moment, and that's proving really interesting. So if we end the poll at that point, Chris. It just remains for me to say a massive, massive thank you to all of you for listening. Max, I've already mentioned a couple of books. We'll come on to the questions in a moment. But if you're, if you're interested in finding out more, connect with me on LinkedIn. You can contact me through my Experimentus email address. And I look forward to hearing from you. So thank you.
Brilliant. Thank you, Steven. No, I really appreciate it. That was really insightful. I think a few questions sort of coming in now. You can read them, can't you, Steven? So Tony's just asked you, do you agree that there may be instances where final acceptance may be required prior to the release to the production?
Sorry, can you just repeat that question again, please?
Yeah, of course. Yeah. Do you agree that there may be instances where final acceptance may be required prior to release to prod?
Yes, and it's dependent on what it is. And the key is to structure your release process to give you that time, perhaps. So one of the other tools that is often used within DevOps releases is the idea of tagging. So in effect, you tag your code so that it is active and available in a test environment, but as soon as upon release, it is inactive. And you run tests to show that if it's active, you can do what you need to, and if it's inactive, you cannot reach it and it doesn't impact. So you can carry on releasing into production whilst you manually go away and test in a test environment. If it proves to be fine, you potentially don't have to release anything. All you do is change a tag in your production environment and the functionality becomes available with no releases needed, or let's say no further releases needed. So yes, and absolutely it may be needed, but then you structure your release, your pipeline, so that manual testing doesn't delay your releasing into production. Does that help?
Yeah, that sounds like you covered it for me. There you go. Tony's just responded saying, thanks, he's familiar. We'll tag and build an understanding that point. So it's a good answer from you there, Steven.
Yeah, no, lovely. Thank you.
Hisham has a question. Are processes like these better suited for mature organizations with stable environments doing more frequent releases rather than small projects?
In some cases, smaller projects may be easier to change because they are small. And as long as you've got the engineering practice in place, it gives you an opportunity to change that rapidly. The flip side is that if you have got uncontrolled test environments, your test data is monolithic, and and you, you know, some organizations struggle just to anonymize data, let alone to make it available on demand in multiple environments. It's breaking down the problem areas and dealing with them one at a time. And if you make a small change and it improves your test data, and you're not in a DevOps organization, but an improvement in test data, for instance, will immediately support you in the testing that you need to do. So you're immediately reaping the rewards of that without necessarily the need to go fully into DevOps. And the whole idea here is that if you continue to make small improvements with your end goal being DevOps, it may take time to get there, but every step of the way you are reaping benefits. Unlike trying to change a whole organization, going from one methodology to another, which has its pitfalls. I'm sure there's many people here who've been involved in organizational reorganizations and whole scale moves to various methodologies that have failed, and the failure is because the move is so big. Whereas within DevOps, if we apply the DevOps principles themselves of small change, incremental, quickly done, we avoid the pitfalls and reap the benefits as we go along.
Amazing. Thank you, Stevan. Any questions from anyone else? Thank you, Tony and Hisham, for sending your questions in already.
Yeah, I can see Max has asked, are there any books? There's a lot of books out there.
Yeah, you mentioned a few before.
It's just picking the ones that work for you. Now, I mean, to me, the first one is read the Phoenix Project. There is a second version of that that's come out, which I think is the Return of the Phoenix, but that embellishes it. Start with those. That they are written as a story that really helps. The structure of that book is actually based on the Goal by Elijah Goldratt, and again, that's another good book to read. That is about just-in-time manufacturing, which is arguably a predecessor and part of the whole lean movement. So there's well worth a read there. There's the DevOps Handbook, which is far more. It's written more as a guidebook as opposed to the Phoenix Project, and again, that is worth read. There's whole sections in there about testing, how testing can get involved, and what it needs. But it also talks about each area and how each area can handle things. And just generally have a look around. There's lots and lots of information out there.